Good day, foundation phase potential mathematics teachers. And we're going to do the revision for the exam. So far, the feedback that I'd like to give you on the two assessments that we've done so far, which is assessment 1 and 2, I can say that about 80% of the students did very well in those assessments. And our last hurdle is the exam. The two assessments have a weighting of 20% and the exam has a weighting of 80%. So you need to go through the study guide and go through all the topics under Unit 1 up until Unit 6. All the work covered for the year is what will be in the exam. I'll just be covering on the main points that I think everybody should be aware of for the exam so that coming to the exam, we don't have anybody with questions or misconceptions about certain topics. I'm going to begin with our outcomes on what you should be able to do by the end of the module, because this is an exit module, meaning that when you finish this degree, you should be able to do the following things. Number 1, you should be able to apply and evaluate key terms. When I'm referring to key terms, I'm speaking about understanding what mathematics is, understanding what counting is, having a number sense, and being able to use basic mathematical concepts such as number operations, geometry, patterns, measurement, data handling. You should understand the theories that we have and how to use them in a lesson and how to use them also when helping children to develop cognitively. Also, you should be able to identify and critically reflect on mathematical problems in familiar and unfamiliar context, and we'll be looking at case studies. We also need to be able to identify and explain different assessment methods, and that will be determined by the kind of learners that you have and what you aim to achieve at the end of your lesson. Let us start with how to use mathematics. First of all, you need to have a number sense and build a number sense in children to understand mathematics. This involves developing a sense of the size of a number. Children should be able to identify that 50 takes longer and more actions to count than 5 does, but 250 takes a lot more. And 5 counters can be held in one hand and 50 in 2 hands, and 250 require a container or many more hands to hold such a thing. So when children have a number sense, if you don't develop the number sense in children, they're unable to make the required predictions on what they need to do in order to solve a specific problem. So when we mean a number sense, it means that they understand the complexity of a number, the size of a number, how muchness, and how small a number is. So being mathematically proficient has 1, 2, 3, 4, 5 things that you need to be competent in. Number 1 is having a conceptual understanding. If you have a conceptual understanding, it means that you understand what it is that you are doing. You need to have strategic competence. That means being able to apply what you have learned, knowing how to do the sum. If they say add, you know that the number needs to increase. Being able to have adaptive reasoning. When you're given a sum, you need to understand that you need to be able to multiply, or does this require me to subtract, or does this require me to add? So that mental process is something that you as the teacher are going to develop within a child. You also need to have productive disposition. That means you need to engage with the problem in order to solve it. Look at the problem, look at what it requires for you to solve it, and then get in and solve it. You also, at the end of all of this, you should be able to have procedural fluency, meaning that you're able to calculate and compute or do calculations with confidence and understanding. Then we spoke about general mathematics. If you're a maths teacher, you need to know the concepts that you are teaching. You need to know how to do patterns. You need to know how to administer space and shape and measurement. So when it comes to patterns, it's through copying, extending, using matchsticks, tiles, blocks, and other apparatus that children develop a sense of behavior of patterns, and you learn to make predictions. Predictions, what will happen in the future. If this is happening and it's a repetition of what is going on, you also need to know if this is a repetition, then you can predict that the same thing will happen in the future. When we come to space and shape, it is through handling concrete shapes and completing tasks such as building objects, covering, tiling, surfacing, making new shapes and objects that children develop a sense of the relationship and properties of the shape and objects that they are working with. They develop a sense of what is equal lengths, what is equal area, what is unequal, what is bigger, and what is smaller. So through measurement, we see first and informally, and then we use it formally on doing measurements. So informally, we're referring to how muchness a thing is. So informally, you'll be doing calculations using hand measurements. Remember, this is foundation phase. So they'll be measuring how long something is using their body parts. Remember, they at this stage or at this level of development, they're at the stage where they're using concrete, pictorial, abstract approach, meaning that they need to touch, they need to use their senses, they need to see things, they need to be doing the things themselves for them to have that mental building block on understanding how to do mathematics. And it's through measuring that they also meet up with situations which cause them to think about the need for the parts of a whole to describe certain quantities. And it's an important introduction to the concept of fractions. So if I'm measuring parts of a body, by using my hands, I was able to measure halfway through the body with my hands and I got to the waist. And by measuring or using 20 hands, I got right up to the head of the person that I'm measuring. Through this, we are collecting information. You need to also expose them to data handling. Data is through the collecting and sorting of physical objects that children develop their first sense of what it means to work with data. So now, in all of this, it requires lesson preparation. When I ask for a lesson preparation in the exam, there are certain aspects that I'll be looking for in the exam. First of all, you need to understand the structure of a lesson plan. Remember, a lesson plan has the beginning, the middle, and the end. So when you begin your lesson, you begin with a hook. By a hook, I mean something interesting that will catch the learners and make them interested in whatever content or concept that you're about to teach. Then you have your introduction. Your introduction should link to prior knowledge that they have, linking with whatever interesting thing that you've linked it to and what they already know and link it to the new concept that you're trying to teach. Then you make your intentions clear. In a lesson, children need to know what it is that they need to know by the end of the lesson. We do this by doing objectives and outcomes. These are the things that they should be able to do by the end of the lesson. Then you have your body of your lesson, which is the main part of the lesson. That is the part where you use your knowledge of patterns, numbers, the way you deliver the content across on shape, space, measurement, addition, having a number sense. This whole collaboration and problem solving, teaching them the steps on how to solve certain problems, how to do certain sums, what are the things that they need to look out for, what are the key elements that they are doing when they're doing this operation. Let them do it and then build onto that. Remember, they're moving from concrete, use pictures, and then move on to symbols and abstract. Then you have the closure of your lesson. Once you've covered all that knowledge, remember, lesson doesn't have to take one particular day. It can lap over onto 2 days. When you do the closure of the lesson, it means that at the end of the lesson, you need to be able to wrap up the information that you've taught the learners, and you wrap it up in such a way that you're able to see the content that you have delivered. The learners have indeed grasped it. There is some knowledge and development that you've placed onto the learners. You do this mostly by doing an assessment. Remember, the assessment has to be relevant to the type of learners and the activity that you have set. So you can do assessment in many modes. Remember, you can do an assessment by doing an observation. You can make them do a written test, and they can also write informally so as they answer questions in the class as you ask them about the topic or the concepts that you've been teaching. So by prompting questions and asking them questions, you'll be able to pick up how many of your learners have grasped the concept that you've been teaching, how many have not, and you need to come up with a strategy that works for all your learners. So now in your teaching, the approaches that you need to use depending on what it is that you aim to get at the end of the day. there are two major approaches that one can use as a teacher. There's the teacher-centered approach, and there's the learner or the child-centered approach. When we're speaking about the teacher-centered approach, if we're looking at the knowledge construction, we're looking at who is going to construct this knowledge. The main person constructing the knowledge is going to be the teacher in the teacher-centered approach. The role of the teacher is that you are taking the leading role, meaning that the learners are quiet. You are the one giving the instruction. You use this most of the time when you're doing a board sum. When you're standing in front of your learners, you're teaching them the steps. It means that they need to use their eyes and ears and their whole mind just by observing what it is that you're doing. So you are taking the leading role, and the learners are passive. Passive, not in the sense of mental process. Passive as in they are seated and focused only solely on you. So your role as the teacher is to look at delivering content in a manner that is interesting, in a manner that is logical. And remember, don't take anything for granted when you're teaching concepts. We teach concepts and we take every little step and highlight the details so that it is very clear for young learners. Remember, we're building the foundation. That's why it's the foundation phase. And if children have not mastered the foundation, it's very difficult for them to continue with mathematics at high school and tertiary level. In this phase, we're going to emphasize learning the correct order of doing things. So we're going to be looking at when it comes to what is the first step that we need to do? The next step, how do we check that we've got the correct answer? They need to be able to pick up whether the answer is correct or incorrect just by looking at the sum. That if I'm adding, there's no way that my answer can be smaller than the number that I began with. It has to be bigger. So those are the kind of things that you need to instill in your learners. Now, coming to the child or the learner-centered approach, this is where knowledge is constructed by the learners themselves. Obviously, not free will. It has to be guided and planned by the educator, but the learner is the one in charge of the lesson. They do this as they are taking the center role. They are the ones going to be doing the activities themselves. You are going to simply be prompting and asking questions. You've laid out the material and you've let them do the activity. So it's almost as if it's a discovery, experiment, a touching, a working out, a self-reflecting lesson where they are seeing and doing, and some light bulb is going off through the learners and they're seeing, oh, yes, I see now why it is bigger. I see why when I pour water into a container that is a different shape, it still fits into the container. Just because it's taller and this one, just because it's a little bit shorter, does not mean that they do not have the same volume. Those are the kind of things that we're speaking about. Then we come to the role of assessment. When it comes to assessment in a learner-centered approach, it's ongoing. You ask for feedback, you do observations, you do oral questions that they're going to be asked. Sometimes you can even do a written assessment where they write the things that they see and have been doing. But the greatest emphasis here will be that children develop a deep learning of what it is that they are doing, because now it becomes internalized in them because they did it themselves. They held it, they touched it, they felt it, they saw it, they smelt it. So they use their senses and make it one with themselves. Then we come to the learning theories. Why do we need to have learning theories? Learning theories help us understand the way children's minds work, so that when you plan your lesson, you understand what it is that is expected of you as a teacher and the developmental stage that children are at, so that you do your material, your delivery at the level that children can understand. If we begin with Van Heel's levels of geometric reasoning and related teaching sequences, we'll look at Pierre Van Heel's observed children developing geometric reasoning and provide a description of the levels through which they evolve, from recognizing figures to being able to develop formal proofs. So he identified 5 levels. The first level being the visualization, analysis, abstraction, deduction, and rigor. So 2 things should be noted at these levels. They are age dependent. Any person at any age who is developing geometric understanding will move through the levels. It is not expected that children will move much beyond the abstraction level until they are well into their teenage years. In other words, there is little expectation that children will, in the foundation phase, reach the deduction and rigor levels. So now, most of the levels, or the ones that will be placing our biggest emphasis on, will be visualization and analysis. So in visualization, it means that children at the visualization stage of their development can recognize figures based on their appearance alone. They will say it's a square because it looks like a square. They can't verbalize exactly what a square is, but because you've shown them the shape and you've repeatedly said that this is the square, they know that this is a square. It looks like a square. And you see that even the language that they use, they're not able to decipher yet that a square has 90-degree angles, sharp corners, 4 equal sides, or that concept yet, but they're able to recognize what the shape is. So however, when they are asked to describe the shape, to sort the shapes, if you have rectangles, if you have squares, if you have polygons, quadrilaterals, they'll be able to identify that these shapes belong to the square family. And if you put them in a pile, they'll be able to see that these shapes belong to the triangular family and these ones belong to the circle, oval families. So they'll be able to distinguish such little elements about shapes. So now we spoke about visualization, and that is the stage that we're going to be focusing mostly on. So when they describe this, this is at the analysis stage. When they visualize, they're able to see and recognize figures based on their appearance. They will also be able to look at shapes through analyzing. So at foundation phase, if you give them a pile of shapes, they can easily sort them in different ways. However, when they ask to describe the criteria they use to sort the shapes, they can do little more than say that the shape in each pile belong together. So analysis, children figure out the properties of this shape, that it has 3 sides. This one has 4 sides. So now we look at the abstraction, where is children at the abstraction stage of their development start to perceive definitions and to give formal or informal arguments to justify their thinking. It's not expected that many foundation phase children will reach the level of abstraction. Then we get to the difficult part of deduction and rigor. Deduction and rigor, although we do not expect children in foundation phase to reach these levels, they are described here for completeness so that you understand the whole Van Heel's level of steps of understanding geometry. So at deduction level of thinking, children can construct proofs with the understanding of the roles of axioms, definitions, and they understand the meaning of the necessary and sufficient conditions. At the rigor level, children begin to understand formal aspects of deduction, and they can develop both indirect proofs by contradiction, in addition to identifying and describing the levels of geometric thinking. Van Heel described a definition of components of a geometry learning experience, which supports children's development. So he focused on free play, focus play, using the correct vocabulary, further focus play, and consolidation. Now, coming to the second person, the father of cognitive construction theory, we focus on Jean Piaget. He maintained that children learn in a continuous process of constructing knowledge. He believed that children acquire information by interacting with the world around them. According to Jean Piaget, children construct knowledge through 2 processes: adaptation, namely assimilation, and accommodation. So when he spoke about assimilation, he was meaning that this happens when children add new information to their existing thought structures. In other words, the new information or experience fits in with what they already know. Accommodation takes place when children make changes to their existing knowledge. So there's new information, and now they're able to make changes to it. If I was today in class, I said 1 plus 1, and they worked out that 1 plus 1 is 2. The next day, when I say accommodation, I say 1 plus 2, and now they see that it gets bigger by 2. I don't have to repeat the same thing. It's something, it's an addition to what they know. They already know that it increases by that number of figures. So 2, because it's a number that has two sticks to it, it gets bigger. So 1 plus 2 now becomes 3. They won't give you the same answer as 1 plus 1, which is 2 again. So now, by so doing, he says that children develop intellectual maturity. He proposed a series of stages through which intellectual maturity moves. He claimed that these stages are fixed and follow each other, but accepted that there was no fixed time for each stage. Piaget suggests that children proceed through stages of development and that these stages are the same for all children according to their ages. So if we look at the description of the stages that he proposed. If we look at the sensory motor stage, which is the beginning, remember some children, when they enter the school level, will not have gone through an ECD center where they're not exposed to certain things. This is where you have to bridge the gap. You need to use a lot of concrete things in the teaching that you're doing. So children should have, at the 0 to 2 years, the infant stage, been able to use their senses, develop a sense of curiosity about everything, and be able to work their way and navigate their way around the world using their senses. At the preschool age, which is the foundation phase that we're dealing with preschool children that are between 2 to 7. They should be able to use symbolic thinking, proper syntax and grammar, plus imagination and experience to express concepts. Then we come to the foundation phase, which is children from 7 to 11. From here, we are building concepts that are attached to concrete situations. So your teaching should have a lot of touching, doing, seeing, senses. And as time, space, and quantity are understood and applied, remember, time is one of those abstract concepts. So you need to make it into something that is concrete that they're able to understand. And then further, because you cannot teach just at the level that you're teaching at, remember, you need to go a little bit further. We have that the highest level of thinking, which is the abstract. They build them along to the level where they reach the abstract stage. They're able to reason out ideas. They're able to see prior concepts and link them to what is coming to the next concept that you're about to teach. Then we spoke about Vygotsky's theory. Vygotsky spoke about zones of proximal development. When he spoke about this, he spoke about a learner having a gap of knowing and not knowing. So now in Vygotsky, we focus on the importance of language. As a maths teacher, you need to use the correct mathematical language. So children develop what is essentially known so that you can't make mistakes when you trying to say. You need to use the correct terms, plus, add, increase. Those are important things that they need to be looking at. So now when we look at the language, we're developing what they don't know to what they will know. And that area or that gap that you are acting in between as a teacher is the zone of proximal development. This encompasses the difference between what a child knows and what a child can learn with the assistance of more knowledgeable persons, such as you, the adult or the teacher. So in the social interaction, the children learn significantly more and learns deeper because you are going to be the scaffold that bridges the gap between what they don't know and what they know. You do this by giving the child support, by creating that building block and asking probing questions that give the child that experience and knowledge that they need to learn the new skills. So there are many implications to this theory in teaching in relation to the role of the learner and the teacher and the environment. When we're speaking about all of these three things, they need to be intertwined and linked in such a way that you observe, let us first look at the role of the teacher. As a teacher, it's not just a guide on the side, but you are the instrument in developing a child through the process of mediation. Mediation refers to the active guidance, structured intervention in problem-solving tasks. So the teacher must determine the zone of proximal development. Where is the part that my children are not understanding? A teacher must provide structured guidance to learners to enable them to accomplish with assistance something they cannot accomplish on their own. So the teacher can do this by means of giving examples, asking questions, being that scaffolding, sparking interest and stimulation by giving them interesting things to look at. And you should also provide tasks that set out children's actual development level to determine their potential to learn. Teachers must identify what concepts and skills learners already know and use their prior learning to build as a ladder into the next knowledge that they need to jump into. And lastly, we're going to be looking at Brunner. He's also one of the theorists of interest in developing knowledge in children. Talk about inactive knowledge, and he says this is derived from the physical manipulation of objects and the child's own movement. This involves that what the young child is doing, for example, sorting, counting. Examples of inactive learning are moving around in the class, touching something that has the same shape, what the child says, which box this falls under, children using their fingers to count. That is inactive learning. Then we have iconic knowledge. Iconic knowledge is a mental process where children uses pre-representations of concrete objects, for example, using pictures to make understanding of certain concepts. The emphasis here is on visual and perceptual information. An example of this kind of knowledge is where children are provided with a picture of 3 butterflies and are asked to draw a flower for each. So in a child's mind, if you say for each, it means each and every one. They need to know that they need to draw 3 flowers in the drawing that you have. So we're moving on to symbolic knowledge. Symbolic knowledge refers to the ability to use abstract symbols. The goal in mathematics is to reach the highest level of symbolic knowledge. This means that the child will start off by counting 2 red apples, then be able to look at a picture of 2 apples that is iconic, and then eventually use the symbols of 1 plus 1 to equal 2. And then lastly, what I will be expecting in the exam is that you'll be able to do a comparison between the theorists. So you'll be looking at how this theorist began things. You'll be able to critique the theories and which ones have limitations and where can you bring in a different theory to bridge the gap in your teaching of a certain concept, and which theorist you can use to teach problem solving. So when we look at Bruner's cognitive movement, he focused on different learning styles because every person has his or her preferred way of learning through hearing, touching, movement, or seeing. So it is therefore important to develop lessons that can address all these different learning styles in a classroom. In the maths classroom, it may mean that you will have to include some explanation, discussion of the concepts. Sometimes you need to explore the meaning through manipulatives, such as using blocks, pebbles, sticks, touching, seeing the answer. You also need to make room for gender differences. In these modern times, it is unthinkable that there are still often a perception that mathematics is more for boys than girls. The opposite has been argued in research that some adolescent boys struggle more than girls, their counterparts. So in recent times, the emphasis on equality in your teaching. You also need to be looking at who are your gifted learners in your class, how can you extend and accommodate for them. And these learners may often be perceived as non-attentive, naughty, or even dumb. However, there may be exceptional in areas such as reasoning, um, and are looking at memory, problem solving in different ways, other than the ones that you have presented as a teacher. So it's necessary to provide opportunities for creative thinking and divergent approaches to solving problems. We also need to accommodate children that are use more hearing and vision in their learning, and those that have visual or hearing impairments. Learners with any of these limitations have to also be accommodated in the maths class, for example, by explicitly teaching concepts, not relying on incidental learning. Mathematics often relies on visualization, and this may become a problem with visually impaired learners. So, learning difficulties in recent years, the focus has turned away from fixing problems rather than concentrating on how to adapt the curriculum to be more accommodating to learners, as well as methods and strategies that you're going to use to ensure that learners will make meaningful learning of the concepts. And this applies to the teacher. So this teacher must be vigilant in identifying the difficulties and adapt and plan the different ways to teach concepts. This brings us into the concept of inclusive learning. So now we need to be inclusive in our classrooms in the way that we teach. When we teach, remember that we need to use different learning styles. We need to take different genders into consideration. We need to also prepare lessons that have an advanced stage for the gifted or the talented learners and those that have hearing and visual impairments. And lastly, we need to look at children that have learning difficulties. In recent years, the focus has turned away from fixing problems, but rather concentrating on how to adapt the curriculum to be more accommodating to learners who are struggling. So your strategy or method of teaching needs to encompass these learners. And lastly, when you assess your lesson at the end, you need to also be cognizant of the different learning styles in your assessment so that you accommodate most learners, so that you're able to get a good idea or a picture of which learners are understanding your work, because not all learners will be able to express themselves in writing. Some of them are able to express problem solving and their intellect through doing. Some of them are able to show you that they understand through showing you things. They're not able to verbalize it, write it down, but they're able to show you. So the manner that you do your assessments needs to encompass all of that. Without wasting much time, I'd like to say thank you very much. Prepare well for the exam. The exam will be on the 12th of October. And anytime that you experience any problem, please email me immediately. I will be online responding to your emails with a team of other people so that we can help you submit on time and do well in your exam. All the best. Thank you very much, Dr. Mampane.